leader is one who translates vision into reality. We are celebrating lifetime achievement of one such visionary, distinguished scientist and director NRSC, Sri Shantanu Chowdhury sir. He is a highly accomplished and renowned space scientist and engineer who has made illustrious contributions to the design and development of algorithms for data products generation for a variety of missions, from Earth observations to planetary, wide variety of payloads from optical to microwave, panchromatic to hyperspectral, operational at various sites, NRSC, IMD, and ISSDC. Sir has contributed widely in ISRO's remote sensing program. ISRS family is immensely glad to felicitate you for your exceptional contributions to this organization and our country. May I now request Dr. Vinod Bothale, DD NRSC, to felicitate Sri Shantanu Chaudhary sir on behalf of Indian Society of Remote Sensing on the eve of his superannuation. Sir, for doing the honors. A heartfelt thanks to Shantanu sir for being with us. Today, I personally feel privileged to have got an opportunity to thank you for the mentorship you have provided. Sir, may I request you to please grace this gathering with your words of wisdom?
Thank you, Arpita. I think I am audible. Respected Dr. Kasturi Rangan, sir, Dr. Sivan, Dr. George Joseph, Dr. Goel, Dr. Navalgun, Sri Kiran Kumar, Dr. Shailesh Nayak, Sri Deepak Das, Sri Nilesh Desai, esteemed colleagues and ISRS members. First, I humbly thank ISRS and SAC for their kind gesture and providing me the opportunity to talk on this occasion. I salute the leaders and the heroes of the successful IRIS-1C mission. The remote sensing program has confronted the community with many challenges. And I, along with my team, had the opportunity to resolve few of them. One of the earliest challenge in 90s was to provide the user community with data products with international radiometric quality, and we at SAC contributed in designing radiometric techniques for IRIS-1C, 1D, TES, ResourceSat, and Cartosat operational missions. Although ISRO had gained enough experience in optical sensors, we faced challenges to operationalize microwave remote sensing missions in the 2010s. Our team at SAC generated quality data products accepted by international community for scatterometer, megatropics, and ReSat payload missions. In order to generate global datasets at near real time for scatterometer, megatropics, and SARAL missions, it was needed to configure a geographically distributed ground segment. Acquiring data in remote ground stations, including Solwart and Bharti, data transfer to Shadnagar or ISSDC stations, processing and disseminating products to national and international weather forecasting stations. We at SAC, ISTRAC, and NRSC contributed to its conceptualization and implementation of such a ground segment. In later part of the decade, the strategic user community had faced the dearth of high-resolution data. ISRO launched a number of Cartosat series and ReSat-2B series of satellites. We at ADREAM contributed to reorganize the data centers and provide quality high-resolution data for strategic users and generate DM for all neighboring countries. We are now facing the challenge of transmitting large volume of data from satellites to ground stations. we at NRSC have established Ka-band ground stations for polar orbiting satellites and Ku-band ground stations for geosynchronous satellites at Shadnagar, strategic user stations, and at Antarctica. NRSC has carried out aerial survey and delivered DEM, DTM with 50 centimeter posting and 30 centimeter vertical accuracy over the entire Indian coast for INCOIS for tsunami modeling, for floodplains of Brahmaputra, Godavari, and Tapi for flood early warning models. And our instrumented mobile station currently has mapped 2.5 centimeter posting, 5 millimeter vertical accuracy surface models for Chitradurga artificial craters for lunar simulation. In keeping with NNRMS traditions, we have generated land use, land cover, land degradation, and wasteland maps, water body and runoff data, forest loss and forest fire alerts, for flood inundation maps in near real time, urban geodatabases for more than 300 Amrut towns, in finer and finer scales, and improved temporal frequencies. The country is still passing through an asset recording phase, and Bhuvan portal with high resolution data and thematic layers in the background is supporting geospatial activities of more than 100 applications, including GeoManreka, IWMP, NHRR, and SMART, etc. It is time now to proceed from mapping to modeling. Young scientists at NRSC have developed flood early warning models, water balance models, crop simulation models, pollution transport models, etc., in addition to development of new remote sensing applications for mineral prospecting for rock phosphate and diamond, smart sampling for crop incidences, carbon sequestration estimates for the entire forest land, physical and biochemical studies of coastal, riverine, and ocean processes, permafrost studies. At Arctic, we have established flux towers, network of lighting detection systems, network of core stations for recording tectonic activities, resistivity measurements for subsurface tomogram for groundwater and host rock, all to fuel analysis, research, and validation. I thank my mentors, D.S. Kamath sir, Dr. George Joseph, Dr. A.K.S. Gopalan, Dr. Naval Gun, Shri Kiran Kumar ji, Dr. K.S. Dasgupta, Shri A.R. Dasgupta, Dr. K.L. Majumdar, to enable me and my team to realize interesting components of ISRO's mandate. Thank you. Thank you very much.